You guys are back, and welcome to part 2 of our lesson, or our last lesson for chemistry. I'm so sad. Today we are going to be talking about not what compounds are, but how compounds are actually formed. And you're going to be able to draw me different types of compounds. Before we get there though, I want to teach you something that typically you wouldn't learn in grade 9. You would actually normally learn this in grade 11 chemistry. So why am I teaching it to you now? It is the world's best shortcut. So we're going to learn what's called the Lewis diagram. So a Lewis diagram, all that a Lewis diagram represents is our valence electrons. It doesn't have the inside electrons, it doesn't have neutrons, and it doesn't have protons. Why is it just showing me the valence electrons? Because when you're looking at forming compounds, when you're looking at forming chemical bonds, that's what we have in compounds is chemical bonds, all that actually interacts is our valence electrons. So in a Lewis diagram, we place these electrons on what we call an invisible box rather than a ring. So good news for me, there's going to be no more circle drawing. I'm super excited about that. So we are going to be drawing how many valence electrons we have on this invisible box. So I've shown this with your dotted lines here. And I'm going to be placing my electrons just like I would for a Bohr-Rutherford diagram. So what we're going to do is we're going to go through and we're going to practice and we're going to see how much easier Lewis diagrams are going to be. So I've got this diagram here. And we're going to go through and we are going to draw ourselves some Lewis diagrams. So if I take a look, let's get myself a big fat marker here. There we go. If I take a look at hydrogen, hydrogen is in the first row, so it has one valence electron. No? Hello? Did I go too thick? I'm on the eraser still. Let's try this again. There we go. So hydrogen is in the first column, so it has one valence electron. Lithium also has one. Sodium has one, and potassium has one. Beryllium is in the second column here. So beryllium doesn't have one, it has two. Magnesium has two, and calcium has two. Boron is one step over, so boron has one more than beryllium, so it has three. Same with aluminum. Carbon is one more step over, so it doesn't have three, it has four. And silicon, right below it, also has four. Nitrogen is the next step over, so it's going to have 5 valence electrons, same as phosphorus. Oxygen is going to have 6. Notice I'm still trying to fill these in the correct order that you would for a Bohr-Rutherford diagram. And the last one, the halogens, is going to have 7. They're only one away from being full. Now, I'm sure you're probably wondering why. Oh, this is what happens when I talk and teach at the same time. We got an extra one here. Just my dog. Don't mind him. So fluorine has 7, and then chlorine is also going to have 7. Why did I not show the noble gases in here? I didn't show the noble gases because they're technically full, right? So the noble gases themselves would have 8 valence electrons. They'd look like this. Well, why we form compounds in the first place is to make an element stable. Remember, noble gases are already stable, so they're actually not going to be involved in chemical bonding. So if you wanted to draw the noble gases in, the noble gases are going to have a valence shell that looks like this, but we're really not going to be looking at them today. Now that we know how to draw Lewis diagrams, we're going to go ahead, continue on with our note, and we are going to look at our 2 different types of compounds. So this first bit of the note is review. You can read it over yourself. I'm going to get right into this, and I'm going to start by talking about ionic compounds. So ionic compounds are between a metal and a nonmetal. Ionic compounds are the first way that an element can become stable. So I'll show you an unstable element and how they can go through and become stable. In an ionic compound, we are going to have ions form. So you're going to see the gain or the loss of electrons. And that bond, that chemical bond, because ionic bonds are our first type of bond we're talking about, it happens because you're going to have 2 opposite charges. So I want you to think about them as magnets, right? You have a positive, you have a negative, and they're actually going to be attracted to each other. Our first element, or our first compound that we're going to look at is going to be sodium chloride. I love to talk about this because we saw sodium. Sodium, when you drop it in water, catches on fire. Super reactive. Chlorine gas is very toxic, but then it forms table salt, which is something that you can totally eat. So let's see how sodium and chlorine can work together to become stable. Sodium chloride has sodium as our metal, and it has chlorine as our nonmetal. So we're going to go ahead and we're going to look at how we would draw sodium chloride. So for sodium chloride, we always ask that you start with our rough work. So we're going to be using Lewis diagrams to make our life so much easier. And we're going to draw a Lewis diagram for sodium, and we're going to draw a Lewis diagram for chlorine. So sodium is going to have 1 valence electron. Chlorine is going to have 7. 1, 2, 3, 4, 5, 6, 7. So sodium and chlorine are going to work together in order to become full. Now sodium is not full, it's looking to give away 1 electron. Chlorine is not full and it's looking to gain 1 electron. Look at how lovely this is. So sodium is going to give up an electron. And where's it going to give that electron to? It's going to give it to chlorine. So let's take a look at how you would actually draw this. How would you represent the compound sodium chloride? Well, sodium at the end of all this will have given up its electron, and chlorine at the end of all this will have gained the electron from sodium. By sodium giving up an electron, it's formed an ion, so we need to tell you that based on the square brackets, and chlorine has done the exact same thing. What's the charge of a sodium ion? Well, I really hope that you did that little cheat that I told you, that you wrote a +1 at the top of this column, and you wrote a -1 at the top of this column. If you didn't, you can always figure that out. I've lost a negative, therefore I must have an overall positive charge, and I've gained a negative, therefore I must have an overall negative charge. Let's take a look at the next one. Let's look at calcium oxide. So we have a calcium, we have an oxygen. Same idea, we're going to draw ourselves our rough work. So calcium is going to have 2 valence electrons. Oxygen is going to have 1, 2, 3, 4, 5, 6 valence electrons. So calcium is looking to give up 2. Oxygen is looking to gain 2. Well, that sounds perfect. So calcium is going to donate its 2 electrons to oxygen. What's that going to look like in terms of a diagram? Well, calcium has given up its 2 electrons. Oxygen has gained calcium's electrons. By calcium giving up electrons, it's now become an ion. By oxygen gaining electrons, it's now become an ion. Oxygen's gained 2 negatives. Calcium's given up 2 negatives, so it's going to be a 2 positive charge. What I want to point out here now is the idea of charge balance. +1, -1 adds up to 0. +2, -2 adds up to 0. That's always going to happen in ionic compounds. As a whole, this compound's not going to have a charge. These charges are always going to cancel itself out. What I want you to do now is I want you to pause the video and I want you to try this one by yourself. And you're back. So you either pause the video or you're looking ahead. Either way. So what I want to point out is that there's this little 2 that I just squeezed in. That's the word I'm looking for, squeezed in there. So I have 2 lithiums and I have 1 sulfur. Each lithium has 1 valence electron, and my 1 sulfur has 6 valence electrons. So why is there a 2 here and why is there not a 2 over here? Well, look at how perfect this works out. Each lithium is looking to give up 1, and sulfur is looking to gain 2. So sulfur is going to gain an electron from here. Sulfur is going to gain an electron from here. And now sulfur is considered to be full. So sulfur now has a full valence shell. It's formed an ion, so I want to put my square brackets around here. And I had 2 lithium, so I'm going to draw 1 lithium here. And I'm going to put 1 lithium here. Those 2 lithiums each gave away an electron. And this is going to have a positive charge. This is going to have a positive charge. This over here is going to have a 2 negative charge. So again, if I go through and I add these up, I have 2 positives, I have 2 negatives, and I'm going to find that I have charge balance. Okay, so those are ionic compounds. Ionic compounds, you see the formation of ions, and we call it stealing. I call it stealing. So ionic compounds are stealing electrons. You actually see electrons leaving one atom and going to another atom. Let's take a look at our other kind of compound. And our other kind of compound is this idea of the covalent compound. So a covalent compound is going to involve the sharing of electrons. So not the stealing, the sharing of electrons. We're going to see atoms are going to share electrons, and we're going to see that this is always between 2 nonmetals. So ionic compounds, we saw a metal and a nonmetal. Now we're going to see 2 nonmetals. Our first example I want to look at hydrogen and I want to look at chlorine. So we have 2 nonmetals, one being hydrogen, the other one being chlorine. So let's pull up there we go. So again, I want to start to show how this is going to work by drawing my rough work again. And my rough work is always going to involve my Lewis diagram. Now here, remember, you're still going to try to get a full valence shell, but we do it a different way. When we have 2 nonmetals, they don't have the ability to steal each other's electrons. So they can't actually go through, and you can't see a transfer of one electron to another atom. So instead, they're just going to share. So what we do is when we're going to share electrons, look at this chlorine wants to gain 1 electron. This hydrogen wants to gain 1 electron. Neither one wants to give up their electron, so we're going to call it sharing. We're going to circle it, and these 2 electrons are going to be shared. So sometimes chlorine is going to be full, and it's going to be happy, and sometimes hydrogen is going to be full, and it's going to be happy. Now this looks really messy, so we're going to redraw a good copy. And what we do when we show the sharing of electrons, instead of including that circle, because that takes up a lot of space, we just draw a straight line. This straight line means that there is 2 electrons being shared between this atom and this atom here. So remember, you always want to have a full valence shell. Chlorine to be full is going to have 8. Well, it has 1, 2, 3, 4, 5, 6, and this line actually counts for 2. So 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen only wants 2 to be happy, so hydrogen's got 2. It is happy. Let's try, and so this is kind of fun because it gets to be like a puzzle. So we just had to figure out how to make this puzzle happiest. So we're going to draw ourselves a carbon, and we're going to draw ourselves 2 oxygen. So I'm going to go ahead, I'm going to put my carbon in my middle here, and I'm going to put my oxygen here, and I'm going to put my oxygen here. Now I'm sure you are asking yourself how I knew to do that. And the answer is going to be years of chemistry practice. So you're going to get really good at this. My grade 11s always start with this. So we always start with this in grade 11 chemistry again. And remember, like I said, it's a puzzle. So we want to see how we can make everything happy. So this oxygen has 6 valence electrons. It's looking to gain 2 electrons. This oxygen's looking to gain 2. And this carbon here is looking to gain 4. So how can we share these electrons in order to make this happy? Well, I'm going to see that this oxygen is kind of close to this electron, so it's going to share. And this well, look I see these electrons are kind of close to each other, so this is going to share. And look at these 2 are right next to each other, so this is going to share. And these 2 are right next to each other, so this is also going to share. Now this looks really messy, so we're going to redraw this. How we're going to redraw this is any time that I drew a circled electron pair, I'm going to replace that with a line. So everything else stays the same. But anytime I have a circled electron pair, I'm going to replace it with a line. So I have 1 circled pair here, so I'm going to put a line. And I have another circled pair here, so I'm going to put a line. I have 1 circled pair here, line, 1 circled pair here, line. Let's count to make sure everything's happy. So this oxygen has 1, 2, 3, 4, and remember lines count for 2, so 5, 6, 7, 8. This oxygen also has 8, and this carbon has 1, 2, 3, 4, 5, 6, 7, 8. So everything is happy. I want you to take a guess at what you call these bonds. So this bond here was a single line, so we call it a single bond. This here, I have 2 lines, so we actually call this a double bond. I want you to go ahead and pause the video, and I want you to try to figure out this one here. And you're back. So we are going to see that we have 1 carbon, and we're also going to see that I have 4 hydrogens. So again, you're going to get really good at trying to figure out how this works. If you're having a hard time, what I recommend for beginners for here is actually draw each individual element on a square piece of paper and arrange them on the table in front of you. That way you can kind of move them and you can try to figure out how to make everything happy. So each hydrogen has a single electron. Notice I'm cheating. I'm taking the electrons and I'm pointing them inwards. That's because that's the direction they're going to share. You can totally do that. You can take that electron and you can point it wherever you want. Each carbon has 4 electrons. So I'm hoping now that I've arranged them this way, you can see that we're going to share, and you can see that we're going to share, and we're going to share, and we're going to share. This again looks really messy, so I'm going to draw it in good up here. I'm going to put here a bond, here a bond, here a bond. We're just gonna, there we go. And then here, we're gonna put a bond. This here is a substance that we've actually formed methane. That's methane gas. Methane gas is actually the gas that comes out of the Bunsen burner. So when you're actually looking at methane, this is methane gas here. One more thing that I want to talk about, and the last thing I want to talk about is going to be diatomic molecules. So diatomic molecule is a molecule that forms when we have 2 atoms of the same element. So we're going to have 2 atoms of the same element joined together. What we're doing in a diatomic molecule is we are trying to make it stable. So there's a bunch of elements that are very unstable when they're by themselves. So a diatomic element means that it's going to come together to become stable. The word di, you might have heard it before, just means 2. So a diatomic element means that we have 2 elements of the same type that are coming together. So again, sounds a little confusing, but let's take a look at an example first. So our first example that we're going to look at here is going to be chlorine. So I've got this 2 here, means that I have 2 chlorines coming together to become stable. So I'm going to draw myself first my Lewis diagram of chlorine. So I've got my Lewis diagram of chlorine, and if you can see, we're actually going to have these 2 electrons are going to be shared. So my chlorine gas, oh, I forgot my L. My chlorine gas, when it's stable, is going to look like this, where every time that I have chlorine gas, it's actually sharing 1 electron pair. I want you to try oxygen. I want you to try nitrogen. Pause the video. I'm going to go let my dog out. You try these and I'll be right back. And I'm back. All right, so hopefully for oxygen, you had an oxygen and you had an oxygen, and each oxygen has 6 valence electrons. So we can see that these 2 electrons here are going to want to share. These 2 electrons here are going to want to share. And if I draw this out, I'm going to see that oxygen always forms a double bond with itself. Nitrogen, if we draw our Lewis diagram of nitrogen, we're going to see that I've got 5 valence electrons, and we're going to see that these 2 are going to share. And I'm just going to use a line here. These 2 are going to share, and we can see that these ones are also going to share. Again, this doesn't look great, so we're going to go ahead and we're going to draw out our good copy of this. And here's something we haven't seen before. Any guess at what 3 lines together means? It's a triple bond. So nitrogen is going to form a triple bond with itself. Now, diatomic molecules, why do we have diatomic molecules in the first place? There's certain elements that are considered to be unstable by themselves. So when they exist in nature, when they exist by themselves, they are always going to form diatomic elements. You do have to know which elements are diatomic. So we use this term in chemistry. It's your first bit of memorization you got to do in chemistry. We use this term, we call it Hofbrinkel. So Hofbrinkel, some people like to envision Hofbrinkel the clown or Hofbrinkel the older lady. Whoever you picture in your head Hofbrinkel to be, Hofbrinkel helps you to remember which elements are considered to be diatomic. So hydrogen, anytime you see hydrogen by itself, 2 is going to be next to it. Anytime that you see oxygen by itself, 2 is going to be next to it. Fluorine is always going to have a 2. Bromine is going to have a 2. Iodine is going to have a 2. Nitrogen is going to have a 2, and chlorine is going to have a 2. That's to make it stable. Chlorine gas on its own is very toxic. Oxygen on its own actually makes free radicals. By having the 2 there, you've gone through and you've made those single elements stable because they're going to form bonds with themselves. This is going to be really important in grade 10 chemistry, so try to remember Hofbrinkel. That's always your diatomic elements, and that's always going to be forming 2. All right, thanks so much for sticking with us, guys. That's the end of chemistry. You have a little bit more homework that I gave you in the online content section. Stay tuned, and we're going to be starting physics. All right, we'll see you soon. Bye.